Hello students, you are welcome back to class. Yes, I wanted to inform your friends that the class has started. Okay, all right. So I want to believe that you have a nice time today. Now let's quickly inform our friends. Let's let them know the class has started. And can you quickly share this video with your friends? Let them know, your classmates and your neighbors. Let them know the class has started. Okay. All right, so we are going to be continuing from where we stopped the last time. Okay, so but before we start, let me give you a few seconds so that those that are yet to join will join, and we're able to start with a very good number of students. Okay, so once you are in the class, I want you to say hi. Just let me see you drop in a greeting. Okay. Yes, technically we are waiting for others to join the class. Once you are available, I want you to say hi, all right, so that we know those that are online now. Okay, if you are just joining and your friends are not here, you can just connect with them, let them know the class has started. Okay, I can see Huba here, and also I'm seeing Mark. All right, you're welcome to class. Okay, let's wait for others to join before we start. Okay. Yes, I can only see two people here. All right. Okay, so why they join us? Now let us just review what we did the last time. So from there, we now move down to what we have for today. Yes, the last time we looked at some problem under triangle, how to solve sides of a triangle, a given triangle. So we learn how to make use of Pythagoras theorem to solve our problem, right? And before yesterday class, we also looked at properties of triangles, and we look at different type of triangles. And I also said something that we are going to be making use of trigonometrical ratio to solve triangle problems. And that is what we are going to focus on today, right? So, okay, so about starting, now let me see how many of us are available now. Okay, good. I can see good number. All right, I can see Molara is here now. Okay, I can also see, okay, Uba is here, Banjo is here. All right, Oluwatosin, I can see that. Okay, all right, I think we are beginning to have people joining. All right, so I quickly want to ask us one or two questions before I commence. All right, I told you the last time that we can make use of trigonometrical ratio to solve some problems. So we looked at this on the board. So-ka-tua. So-ka-tua. Now, and I told you that sine, S represents sine, O represents opposite, H represents hypotenuse of a right angle triangle. The same thing also applies to this. C is cos, A is adjacent, and T, okay, this is supposed to be H, sorry, car. So this is hypotenuse, all right? And then we have tua, that's T for tan, O for opposite, and A for adjacent. Okay, now let's draw that in a right angle triangle. Now, if this is the reference angle, okay, so I have A, B, and C. All right, now let's quickly check whether we still remember what we did the last time. Can anyone in the class now tell me what is A, what is B, and what is C? What is A, what is B, and what is C in this diagram? Okay, now let me redraw the diagram. Okay, so it seems I made it very simple. Okay, now look at the diagram now. All right, let's look at it now. What is A, what is B, and what is C? I need you to tell me which one is the hypotenuse, which one is the opposite, and which one is the adjacent. Okay, so that is what I want you to do. Do that and drop your answer in the comment section. Let me see. Your answer here. Okay, opposite, adjacent, and hypotenuse. What is A, what is B, and what is C? Yes. All right, I have Omolara. A is hypotenuse, B is adjacent, and C is opposite. Okay, that is your answer. All right. Okay, I can see Huba now. A is hypotenuse, B is adjacent, and C is opposite. Now I'm waiting for others to drop their answers. Okay, I'm waiting for Muiz. I think I can see Muiz here. And who else am I seeing here? Okay. All right. Uber have A is hypotenuse, B is adjacent, and C is opposite. Okay, because of our time, now let's look at it. Now, the last time I told you, identifying your hypotenuse is the very easiest thing. It's very easy. Now, the side that is facing the right angle is the hypotenuse. Now, look at it now. This side is facing the right angle. So, this is the hypotenuse. So, A is hypotenuse. This is your hypotenuse. Okay. Now, adjacent is the side that is touching the reference angle and right angle. So, we have this, the reference angle, and this is right angle. So, B is opposite. Adjacent, sorry, this is your adjacent, and C is your what? Your opposite. Since you know this one is adjacent, so that means this is going to be opposite. All right, so that is how to locate that. Now let us now get our trigonometrical ratio for this. Now we have sine theta equals to opposite over hypotenuse. That is opposite over hypotenuse. Right? Now cos theta is adjacent over hypotenuse. Tan theta equals to opposite over adjacent. Okay, good. Now we want to look at tan, sine, and cos of these following angles. We call them special angle. Angle 45, 60, and 30. All right, now, so I'm starting with angle 45. So sine, cos, theta, and tan theta. Now let's look at our right angle triangle. And our theta is 45. So theta is 45 this time around, 45 degrees. So this is 45. And of course, now, if this one is 45, you know this place too is going to be 45. That means this side and this side must be equal. So I'm putting 1, this 1, this is going to be 1. Let's just say 1 unit and 1 unit. We can get this because the addition of this and this must give you 90. Since this one is 90, this angle here are complementary. So when you add together, it must give you 90 degrees. So if this one is 1 and this one is 1, now let us get the hypotenuse. Okay, now let's do that. Let's get the hypotenuse, making use of Pythagoras theorem. Okay, now we have in this diagram, let's represent the hypotenuse with h. So we have h squared, the hypotenuse square, equals to opposite square, 1 square plus adjacent square, that's 1 square. So hypotenuse square equals to 1 plus 1. So hypotenuse square equals to 2, and the hypotenuse is going to be square root of 2 units. So that means we have square root of 2 units. Okay, so now we can get the sine, cos, and tan of 45 from this diagram. Now let's do that. Sine 45 is what? Look at sine. Sine is opposite over hypotenuse. So opposite over hypotenuse, that is 1 over square root of 2. So we have 1 over square root of 2. You get that? Now let's move down to the next one. Cos 45. Now we have cos 45 will be what? Adjacent over hypotenuse. That's going to be 1 over square root of 2. 1 over square root of 2. And the last one is tan 45. What is tan 45? Opposite over adjacent. That's going to be 1 over 1. So 1 over 1, which is the same thing as 1. Okay, so now we now have the value of this special angle, 45 degrees. All right, so sine 45 is 1 over square root of 2. Cos 45 is 1 over square root of 2. And the tan 45 is 1. So we are going to take note of these values because we are going to be making use of it. So now let me write that here. Let's keep this. So sine 45 degrees is equals to cos 45 degrees is equals to 1 over square root of 2, and tan 45 is 1. Tan 45 is 1. Okay, so let's take note of this. We are still going to refer to it. All right, now let us now get the value for sine, cos, and the tan of 60 and that of 30. Now let's do that. So I'm going to be looking at an equilateral triangle. An equilateral triangle. Let's look at it together. Equilateral triangle. So let's say we have 2, 2, and 2. When we say equilateral triangle, that means all the sides are equal. So if all the sides are equal, it means all the angles too are equal. So it means each of the angle is going to be 60, 60, and this place is going to be 60 as well. But now I want to divide this angle into 2 parts. So it's going to be into 2 equal parts. So this is going to be 30 degrees and this is 30 degrees. So this line is drawn such that it's perpendicular to this. Okay? All right. Now, so let us look at this diagram. I want to get this side. Now let me bring it out. Let me bring this right angle triangle out. So I have there's this right angle triangle where this one is, let's say this is 60. So now this divides this side into 2 parts. So we have 1 for this place and this place is also 1. So what I'll be having here is 1. And this place is what? Is 2. Now I need to get this place. Let me call this place X. All right. So if it is X, I will use Pythagoras theorem now to get the opposite. Now, so I will have x squared plus 1 square equals to 2 square. Okay, using Pythagoras theorem. This side plus this side equals to the hypotenuse square. So we have x squared plus 1 equals to 4. 2 times 2 is 4. So let's take this to this side. We have x squared equals to 4 minus 1. So x squared equals to 3. So x equals to square root of 3 units. Okay, so that means the height here is square root of 3. Okay, I want to believe you understand how I got that. All right, so we can now move down to this. Now let's look at this right angle triangle. Now we now have the value for x. So x is square root of 3. Now the angle here is 60. You can see that I'm using this triangle. I just try and discard this. So I'm using this. Okay. So now I want to get the sine, cos, and tan of 60. So I will come here and write sine 60. Don't forget, sine is opposite over hypotenuse. So this is opposite over hypotenuse. So sine 60 is going to be square root of 3 over 2. Okay? Now let us look at cos 60. Cos 60 is adjacent over hypotenuse. Adjacent over hypotenuse. This is my adjacent. This is my hypotenuse. So that's going to be 1 over 2. So that's 1 over 2. Okay? Now, the last one is tan 60 degrees. Okay, that's opposite over adjacent. Opposite over adjacent. So that's going to be square root of 3 over 1. Okay, so we now have the value of this special angle 60. So sine 60 is square root of 3 over 2. Cos 60 is 1 over 2. And the tan 60 is square root of 3. So we have to keep this one. All right, now let us write it here. So we have sine 60 degrees equals to square root of 3 over 2. Cos 60 degree equals to 1 over 2. And the last one, tan 60 equals to square root of 3. Now let us look at the last one. That is 30. Okay, I'm bringing out this triangle, this same triangle. That's what I'm bringing. And this time around, I'm not considering this one as my reference angle. So I'm considering 30 as my reference angle. So I have 30. So this one is no longer there. So the side there is still square root of 3. This is still 1 and this is 2. Okay, so here, now let us get the sine, the cos and tan of this special angle 30 degrees. So now let's start with the first one. We have sine 30 is opposite over hypotenuse. Where is the opposite? This is the opposite over hypotenuse. That's 1 over 2. So we have 1 over 2. So the next one is cos 30. Cos 30 is adjacent over hypotenuse. That's square root of 3 over 2. And the last one, tan 30 degrees. Okay, so that gives you what? Opposite over adjacent. Opposite, this opposite. Opposite over adjacent. That's 1 over square root of 3. Okay, so, all right, can you see that now? So this is what we have for special angle 30. Now let's put that here too. So we have tan, okay, sine 30 degree equals to 1 over 2. Cos 30 degrees equals to square root of 3 over 2. And tan 30 degrees equals to 1 over square root of 3. Okay. Now this, you have to put this one somewhere in your notes, and you try as much as possible to master this, because when question is given and we have special angle, you're expected to be able to recall this. Okay. All right. Now let's now begin to look at our problems on the trigonometrical ratio. Now let's look at the first example here. Find the value of x and y in the figure below. Now let's look at the figure. This is the figure. X 3 centimeter. This is y. All right, now let us solve this problem together. If you are just joining this platform and you have not subscribed to this channel, please kindly do that, and also give this class a thumb. So make sure you tap the like button. All right. Okay, thank you for doing that. Now let's look at the problem now. So we have to find the value of x and y in the figure below. Now let's look at it. I need to get the value of x first. Now let me do that. So I will consider this. I have to look at it. This is my opposite. This is the adjacent. And this is the hypotenuse. This is what I need to master very well, because if I don't get this one correctly, there's no how I'll be able to get the answer. All right. Don't forget, I said the side that is touching the reference angle and angle 90 is your adjacent. This is your opposite. And your hypotenuse is that side that is facing right angle directly. Okay, so now I need to get x. Now look at it. X, I will connect the side I'm looking for with a given side. So that means I'm connecting opposite and adjacent together. Opposite and adjacent. Okay, can you see that now? Opposite and adjacent, because I don't know this, I know this. I cannot connect this and this together. That means I have two unknowns. So I'll not be able to get anything. So I'm connecting no unknown side with a known side. So, and what I have is opposites and what? And adjacent. So what trigonometrical ratio is that? That's going to give you tan. Okay, so that means I will have tan 45 degrees equals to opposite, which is my x, over adjacent, that's 3. All right, tan 45. Now you check this. Tan 45 is what? 1. Good. So tan 45 is 1. So we have 1 equals to x over 3. So you cross multiply. So you have x equals to 3 centimeters. Okay, so now let us get y. Now you connect this and this, a known side and unknown side. Okay, so now what do I have now? I have adjacent and what? And hypotenuse. So I'm going to be using cos. That's car. Okay, so we have cos 45 degrees equals to adjacent, which is 3, over hypotenuse, and that's y. Now let's look at it. What is cos 45? That's 1 over square root of 2. So I have 1 over square root of 2 equals to 3 over y. Okay. Now here you can cross multiply. So you have y times 1, that is y, equals to 3 times square root of 2. That's going to give you 3 square root of 2. And the unit is going to be in centimeters. So that is how to solve that problem. I want to believe everyone is getting that explanation. All right, now let's move down to another example. Let's take another example. example 2. Let us just look at the diagram. I'm going to be drawing the diagram, so okay, now let us look at the diagram we have on the board. I hope that diagram is not confusing. Now, before I solve this problem, I need you to tell me what is y, what is x, and what is 2. Now, I need you to tell me the name. Is x the opposite or the hypotenuse or the adjacent? Is x the opposite or adjacent? Is 2 opposite or the adjacent? So let's first identify that before we solve. All right, so tell me the answer and drop in the comment section. Let me see what we have. Yes. Okay, I can see. You need to give me the 3 together. Tell me y is either opposite or adjacent, x is so, and 2 is that. Okay, can I see that? Let me see. Yeah, I can see Uber saying x is adjacent. Yes, I need you to tell me all the sides. Yes, I'm waiting for your answer before we continue with the example. Yes. All right. Okay. Y is hypotenuse, x is adjacent, and 2 is opposite. Okay. All right. Okay. I think I've seen what I want. So, yes, I want to believe every one of you still remember what I said. You must be able to identify your adjacent, your opposite, and hypotenuse. You see, locating hypotenuse is very easy. The side that is facing the right angle. So this side. So that means your y is the hypotenuse. Okay. Y now, this is the adjacent. X is adjacent. X is adjacent. Okay. And this is going to be the opposite. All right. So now, to get x now, so I'm connecting this and this together. A known and unknown side. So I want to get x. So now, this is my opposite. This is my adjacent. Okay, so what trigonometrical ratio will I be using? I'll be making use of TWA. Okay, I have my SOHCAHTOA because in TWA I have opposite and adjacent, and that is what I have here. All right, now let us do that. We have tan, what's the reference angle? Tan 45 equals to opposite. Now what's the opposite now? Opposite is 2 over adjacent, and that's x. This is the same thing as 1. We have 1 equals to 2 over x. You cross multiply, you have x equals to 2 units. Okay? All right, now let's get y. So y, you connect known side and unknown side. Don't forget this place is your hypotenuse. All right, now let's compute. So now which one is opposite and hypotenuse? So that's going to be your sine. So we have sine 45 degrees equals to opposite, which is 2 over hypotenuse. Hypotenuse is y. All right, so that's going to be 1 equals to 2 over y. So when you cross multiply, you have y equals to 2 units. Okay, so that is the answer to that problem. All right, now before I move further, I'm going to give you one to quickly try in a minute, and then we continue with the class. Now try this. Find the letter sides. Okay, now can we quickly do this one? Find the lettered side in the figure below. And let's do that and let's see what we have as the answer before we move down to another type of problem. Okay, let's quickly do that. Once you get your answer, drop your answer in the comment section. Okay, what is X and what is Y? We have less than a minute to go. And once I drop in your answer, drop the two answers at the same time. I want to see the first person that is going to give the correct answer. Okay, what is X and what is Y? Find the value of X and Y. So you are given the sides 6, Y and X, and the reference angle is 60 degrees. So by now you should have finished. Okay, good. I can see somebody dropping an answer. Y is opposite and okay. Y is 6. Give me the two answers. What is the value of X? What is the value of Y? Okay, Riscott has dropped an answer. X is 12, Y is 3. Now let's wait for one or two people that will give us their own answer as well. X is 12, Y is 3. Now let's wait for others. Okay, is anybody dropping an answer? All right, we have a few minutes more. We have a few minutes more. By now, we should have finished. Yes. Okay, I can see that it's only one person that is giving us an answer. Or let's say two people. Okay, now let's look at it together. Let's see what we have. Okay, I guess some people are still solving the problem, but because of our time, let's do it together. All right, now let's look up. Now, you have to find the lettered side. Now, the first thing is to identify the opposite, adjacent, and hypotenuse in this diagram. Now, let's look at it. Now, this is the adjacent, the side that touches the reference angle at 90. So, this is the adjacent. Adjacent. Now, this is going to be the opposite, and this is the hypotenuse, the side that is facing right angle. Okay, now the first thing is to get value of x. So that means I'm connecting hypotenuse and adjacent together. So I'll just recall my katua. Okay, so I will look for the one that has adjacent and hypotenuse, that is a and h. That is k. So that means I'm going to be using cos 60. So I have cos 60 degrees equals to adjacent, that's 6 over hypotenuse. And that's what I'm looking for, x. Now, cos 60 is written as 1 over 2. Okay, we have that here. Cos 60 is 1 over 2. So that's going to be 6 over x. So you cross multiply. So we have x times 1, that is x, equals to 2 times 6, that's 12. So that is going to be the value of x. Now let us look at the value of y. Now y, I'm connecting this side and this unknown side with a known side. So that is opposite and adjacent. Opposite and adjacent. Look at it, opposite and adjacent is 12. Opposite, adjacent. So I'm using tan. So tan 60 equals to opposite. What's the opposite now? That's y over adjacent. That is 6. I have 6. Now don't forget that this is square root of 3 equals to y over 6. Now you can see that tan 60 is square root of 3. So you cross multiply. We have y equals to 6 square root of 3. And this is going to be the answer. So we have 2 answers for that. So, all right. I think somebody got part of the solution. All right. But the second is 6 square root of 3. Okay. So I want to believe you all understand that explanation. Okay. So we are moving down to something else. Okay. Now let's move down to something else. In the figure below, find A and B. So this is A, this is B, is 60 degrees, This is 30 degrees. 16. All right. Now let us look at this problem. Okay, I have to examine this diagram very well. So I need your attention. Let's see how to solve this problem. Now, the first thing is to look at the diagram. Which right angle triangle do we have there? We have one here. You can see this one. We have a smaller one. We also have a bigger one. All right. So when you look at the smaller one, let's look at the sides we have there. We have the opposite, which is A, and the adjacent, which is Y. sorry. Okay, I want to believe you can hear me now. All right, so let me quickly go through what I just said now. Now, I'm considering the first triangle, which is the smaller triangle, that is opposite and adjacent. Opposite and adjacent is what? Is 2. So we have tan 60 equals to opposite over adjacent. That's A over B. And the tan 60, when you cross multiply, you have A equals to B tan 60. All right. Tan 60 is square root of 3. You can see that here. All right. So you have A to the this. So let's take note of this. Okay. Now, let us now look at the bigger right angle triangle. Now, when you look at this bigger right angle triangle, 30 degree is the reference angle, not this one. Because this is what you are looking at. So you just disregard this. So you are looking at this. So I'm considering the opposite and the hypotenuse, a known side and unknown side. Okay, so opposite and hypotenuse, and that is your soul. So I'll have sine 30 equals to opposite, that is A over hypotenuse, that's 10. Don't forget your sine 30 is the same thing as 1 over 2. So I have 1 over 2 equals to A over 10. So let's cross multiply. So you have 2A equals to what? 10. And then we have A equals to 10 over 2. Then A equals to 5. Okay, so that's the first part. Now let us now get the second part. All right. Don't forget, A is the same thing as B square root of 3. So I'll just plug in the value of A into this equation here. Let me do that. So when you do that, you'll be having from here, so you have 5 equals to B square root of 3. All right, so you can divide both sides by square root of 3. So we have B equals to 5 over square root of 3. So, and now this is going to be the answer. So we have A to be 5 and B to be 5 over square root of 3. So you can rationalize this if you care to do that. So you just multiply the numerator and denominator by square root of 3. But let's leave the answer this way. All right, so these are the answer to the problem. All right, I want to believe you understand that. So I'm going to give you another example because of the break in transmission. Let me look at another example that is similar to what we just did now. Okay, now let's look at this. Okay, now let's look at what we have in this diagram. You have to find X and Y. Find X and Y in the diagram. Now to do this, I have to first locate the right angle triangle that we have here. So I have one here. This is a right angle triangle, and I have another one. This is another right angle triangle. All right, now the first one I'm going to be looking at is this because I have one of the side given. Okay, so I won't consider this one yet. So I have one of the side given. So this is the one I'm considering first. All right, now let's do that. So if you consider this, now this is the adjacent. This is the hypotenuse. And this is the opposite. Okay, so I will connect this and this together. The given and the unknown. So that means I have adjacent and the hypotenuse. And that's cos. Don't forget we have so, ka, tua. So C is for cos, A is for adjacent, and H is for the hypotenuse. So we have cos 60 degrees equals to adjacent, which is 3 over hypotenuse, and that is x. So what is cos 60 degrees? That's 1 over 2. We have 1 over 2 equals to 3 over x. So you cross multiply. So you have x equals to 2 times 3. And that is what? X is what? 6. We have 6. Okay. Now, the next thing is to get this. Now, look at this triangle now. None of the side is known. So I have to find a way of getting this side. Okay. So I can make use of Pythagoras theorem. Since this place is now 6. Okay, which is your x. Okay, so let's look at it. We have the opposite square plus adjacent square equals to the hypotenuse square. Let me call this place h, the opposite. All right, so I will have h square plus 3 square equals to 6 square. And that's going to be h square plus 9 equals to 36. Okay, so that's going to be what? H square equals to 36 minus 9. All right, so we have h square equals to 27. Okay, so now let's now look at it. So we have h will be square root of 27. So that's what we have there. So let's see, this is square root of 27. Square root of 27. So now we need to get y. We need to get y. So to get y, I'm considering this side and this side together. Okay. So let me consider this and this. So I'm having this opposite. This is hypotenuse and this is adjacent. So I'm considering opposite and hypotenuse. So opposite and hypotenuse is what? Sine. Opposite hypotenuse. I have sine 30 degrees equals to opposite, which is square root of 27, okay, over hypotenuse, that is y. So sine 30 is 1 over 2. We have that here. Sine 30 is 1 over 2 equals to square root of 27 over y. So you can cross multiply. So you have y equals to 2 square root of 27. This is going to be the answer. So this is the value of y. Yx is 6. Y is 2 square root of 27. Yes, I want to believe we'll all understand that, right? Okay, so let us move on to something else. So I would want you to try this. Let's try something similar to what we have just been doing. Okay. So try this. Find the value of x and y in the figure. Okay, so that is the question. Yes. Now let's quickly try this and let's see what we are going to have. Okay, find the values of x and y in the figure. Okay, now let's quickly try this. Okay, I'm waiting for your answer. Has anyone finished? Yes, let's begin to drop our answer. By now, we should have finished. Now, what is the value of x and what is the value of y? Find the value of x and value of y. So what do we have? So we are going to do the correction in the next few seconds. Okay. All right. Because of our time, we need to solve the problem. Let's solve the problem together and let's see what we have. Okay, you have to find the value of x and y. Please, I want to believe you have all this in your notes because we are going to be referencing all of this. All right, so now let's see. Find the value of x. So how do we get the value of x here? So we look at the first triangle we have here. Look at this triangle. It's a right angle triangle. Okay. And when you look at this right angle triangle, where we have 45 as the reference angle, we have a known side, and that will make me to consider that first. So I won't consider this because I only have one unknown, I don't have any known side here. So I won't consider this. So this is the first thing I'm going to consider. So now let us look at it. Now this is like this. Let's bring it out this way. We have 45 degrees. Now we have 2 here. We have x here. Okay, so we need to identify opposite, adjacent, and hypotenuse. So this is opposite, this adjacent, and this is hypotenuse. Don't forget, your adjacent is the side that is touching the reference angle and angle 90. Okay, and the side that is directly facing the right angle is your hypotenuse. All right, so now let us look at it. We connect this and this together. So opposite and your hypotenuse. Now let's look at our SOHCAHTOA. SOHCAHTOA. So which trigonometric function are we going to be using? Okay, we have O and H. So O and H is there. So we'll be using sine function. We have sine 45 degrees equals to opposite 2 over hypotenuse. That's x. Now, what is the value of sine 45? That's square root of 2 over 2, okay, which is equals to 2 over x. Now, you can check your note. Now, this is also the same thing as 1 over square root of 2. I've rationalized it, okay? But now let me switch back to what I gave you the other time. It's still the same thing as 1 over square root of 2. So let's use 1 over square root of 2. Okay, because if I say 1 over square root of 2, if I multiply that with square root of 2 over square root of 2, this is the same thing as 1. So I will still be having square root of 2 over 2, which is the same thing as 1 over square root of 2. But no problem, let's make use of this. Okay, so now you can cross multiply. When you cross multiply, what do you have? X times 1, you have x, and 2 times square root of 2. So you have 2 square root of 2. So this is going to be the value, the answer for x. All right, now we need to get y now. Okay, let's consider the triangle where we have y. So you have this. So this is your right angle. This is y. This is 60 degrees. Okay, x have been determined to be 2 square root of 2. Okay, so I need to connect this and this together. This is the adjacent because this is the side that is touching the reference angle and the angle 90. So this is adjacent. Now this hypotenuse because it's the side that is facing right angle. So this is your hypotenuse and this is going to be your opposite. Okay, so I'm connecting this and this together. That is car. I'll be making use of car. Okay. Oh, sorry. This car is H. All right. So sorry for that. So it's going to be cos equals to adjacent over hypotenuse. Okay. So we have cos 60 equals to adjacent. What's the adjacent? Y over the hypotenuse, and that is 2 square root of 2. Okay, don't forget cos 60 is 1 over 2. We have 1 over 2 equals to y over 2 square root of 2. So you can cross multiply. We have 2y equals to y times 2 is 2y. So 1 times 2 square root of 2, you have 2 square root of 2. So here you can divide both sides by 2. We have y equals to 2 square root of 2 over 2. So 2 cancel 2. Therefore, y equals to square root of 2. So, and that is going to be the answer to the problem. All right, so I want to believe you guys enjoyed the class today. Okay, so we are going to be stopping today. We'll be stopping now. All right, so we are going to continue in the next class. So I want to believe you enjoyed the class. If you enjoyed the class and you want the class to continue, I want you to subscribe if you have not subscribed, and also give the class a like by tapping on the like button. Right? Okay, so do have a wonderful time ahead. Take care of yourself. Bye bye. Mhm.